Hello everyone, welcome to Ganit. Good evening. Today we have finished the midpoint theorem in the previous lecture. We are going to talk about the intercept theorem now, and then we will see a couple of examples on both the theorems. If you remember in midpoint theorem, I had explained you all the necessary points where how you will break a question, how you will decode a question. Something similar will happen in intercept theorem as well. Let's see. So intercept theorem is applicable on three parallel lines. So if you have three parallel lines, let's just say this is L, this is M, this is N. Let's just call this transversal as T1 and T2. Let's call this as A, B, C and P, Q, R. So first part of intercept theorem that we need to understand. What we did similarly in midpoint theorem also was we tried to understand the diagram first. Second thing, we paid attention to what was given to us and then we went to the result. Here also something similar will happen. We will keep our approach pretty similar to that of midpoint theorem. So what we need to understand is the diagram. What are the important conditions for the diagram? Remember, parallel line was present in midpoint theorem also. So sometimes there can be a confusion. Okay. So I will give you specific pointers it will help you in deciding that we are looking at a intercept theorem question or something else. Okay. So first and foremost, you need to have three parallel lines. So three parallel lines are important because you can create two intercepts using three parallel lines minimum. With two parallel lines, you cannot create two intercepts. That brings me to my next question. What is intercept? So you see this space between the parallel lines. This is known as an intercept. AB, BC, PQ and QR. They are known as the intercept. So if you have a couple of parallel lines and you pass a transversal through it, so transversal will cut that parallel line, that set of parallel lines at two different points. That distance is known as an intercept. So coming back to the intercept theorem, so we need three parallel lines. We also need two transversals. So if you have just one set of transversal but three parallel lines, intercept theorem will not work. You need minimum two transversals. What are the different type of diagrams that will come in this question? I will talk about that as well. So I will show you how the transversals may not look as straightforward as you are seeing them right now. The questions may be offering something new. We have two transversals, and then what should be given? That AB is equals to BC. So the theorem says that if AB is equals to BC, given that there are three parallel lines, two transversals, then the intercept made with the other transversal should also be equal. Then PQ should be equals to QR. Remember, what are some common misconceptions? What are some common errors that people make? Remember, AB is equals to BC and PQ is equals to QR. But AB is not equals to PQ. Please remember that. BC is not equals to QR. This does not guarantee intercept theorem. I'm telling you AB is not equals to PQ. That also does not mean that AB cannot be P equals to PQ ever. It can be. If a particular question is giving you that kind of information, very well it can be. But it's not a part of intercept theorem. That's precisely the point that I'm trying to make. AB and BC are equal. So on one transversal you have two intercepts, they will be equal. But it doesn't mean that you have two transversals, this intercept will be equal to this one. No, that's not the intercept theorem. They may be equal for some other reason or may be given by the question itself. But transversal has to be the same. The intercept made by one transversal on three parallel lines are equal. So AB equals to BC, PQ is equals to QR, that's okay. But AB is not equals to PQ. Do not think that. Sometimes I have seen my own students make this mistake. They write AB is equals to PQ. And the worst thing is that they will write by intercept theorem. No. AB can be equals to PQ if the question says. Always remember, the question is supreme. I mean, question is saying something, we'll follow it. We'll not question it. But intercept theorem cannot be a reason for AB being equals to PQ. Remember, AB is equals to BC, PQ is equals to QR. Both your intercepts that are equal to each other should lie on one single transversal, not two different transversals. So I hope intercept theorem is clear to you. Uh, Remember the key points. What do we have as the key points? So key points are, we have three parallel lines and two transversals, and then the result goes like, if AB is equals to BC, then PQ is equals to QR. This becomes your result. Okay, so this is how you comprehend your intercept theorem. I hope you have understood this. Now I am going to tell you how intercept theorem is put up in a question. You may not always get a diagram which is as simple as this. No, most of the times in questions you will not get this. So that brings me to my next point. What are the kind of diagrams we can expect? Let's see. So we have, let's just say, a trapezium, and they pass a line like this. Now this is three parallel lines and two transversals, all right. Do not think of this just as a normal trapezium. Why? Because if you extend it a little bit, see, it became a proper diagram like intercept theorem. So that is what I have been trying to tell. Intercept theorem diagram may not always look like this one. If it does, it's a good day for us. But if it doesn't, then we will not count it as an intercept theorem question. Please understand, intercept theorem question will give you a very, very clear signal that in the diagram there are three parallel lines hidden somewhere. Obviously, you have to search for it. Think about this. You have a triangle, and I am going to show you how easily you can create an intercept theorem situation even if it is not present originally. What do you need to do? You need to pass a line through this and this. This could act as your transversal 1, this could act as your transversal 2. So all in all, for intercept theorem to work, you need three parallel lines and two transversals. Okay, so I hope intercept theorem is clear. Let me pick up a question now on midpoint theorem, and then we will go to a question on intercept theorem as well. I have this textbook with me. I'm just going to pick a good looking, nice looking question, and we will solve it. Yeah, so this is a question which can very easily confuse you between intercept and midpoint, and that's precisely why I'm picking this question. Let's see. So we have this question where they have made a trapezium sort of structure. They call it ABCD. We have another line, and they are calling it PR. They're passing a line through here, that is Q. Okay. The question says, prove that PR is equals to half times AB plus CD. And the question goes on to tell you that the following figure shows a trapezium ABCD. So we have a trapezium ABCD in which AB is parallel to CD. P is the midpoint of AD and PR is parallel to AB. Now please understand, they have given that PR is parallel to AB. You know what that means? AB was parallel to CD as per the question, and they have told that PR is parallel to AB. That means that PR, AB and CD, all three lines are parallel, and we are seeing multiple transversals also. So very easily we can think of this as a intercept theorem question. But is it an intercept question? That's the $1,000,000 thing. So you have to understand, in the question in the beginning they mentioned P being a midpoint. But remember, a midpoint, a solo midpoint, single midpoint. They didn't use two midpoints, they used one midpoint. And they also mentioned that PR, this whole line PR, is parallel to AB. So one midpoint and a parallel line, I think you have guessed it. It's converse of midpoint theorem. So what happens? Because P was midpoint and PQ was parallel to AB, so we'll write because P is a midpoint. How do we know? It's given to us. PQ is parallel to AB. That's also given to us. So remember, converse of midpoint theorem or midpoint theorem question, the first thing we decide is the triangle. Which triangle I am going to apply the converse now? Triangle DAB. I can very easily say Q is also the midpoint. How? By converse of midpoint theorem. Okay, converse of MPT. Now if you solve this further, I have found PQ. So when Q becomes the midpoint, can we say that PQ is half of AB? How? By MPT. When I have P and Q both as midpoints and PQ is parallel to AB, obviously PQ is half of AB. So by till now what I have is PQ is half of AB. Now imagine this. I just shown that Q is the midpoint, correct? Now I'm going to change my triangle, the triangle in which I'm going to search for another midpoint theorem. If you look at triangle BDC upside down, the BDC triangle, we know that Q is a midpoint. We know that, right? From where? From equation number 1. We just proved it. We also know that QR is parallel to CD. That's given to us. What does that mean? If you look at the triangle BDC, one midpoint and a parallel line. Again, by converse of midpoint theorem, R becomes midpoint. Right? That means QR is equals to half of CD. Right? Now, what I'm going to do is, I'm going to write what the question is asking, PR. So PR is basically what? PQ plus QR, correct? What is PQ? Half AB. See? And what is QR? Half CD. That means PR is half AB plus CD. Hence proved. So this is how you approach the question. What I did was, I read the question very carefully. That's the first thing you will do. Second thing, I observed that the question is always talking about only one midpoint. It is talking about a parallel line, but only one midpoint. That means converse of midpoint theorem will come into the play. So I spotted the triangle, I spotted one midpoint, I spotted the parallel lines, and I decided that it is a converse of midpoint theorem question. And I applied converse of the midpoint theorem, and as a result, I was able to solve this question easily. So please understand, reading the question is super crucial. If you read the question looking and searching for the keywords that I have been constantly telling you about, I think you will be finding it incredibly easy to decode a question. You have to search for the keywords. What are your keywords? One or two midpoints? Parallel line? If yes, then either converse or the midpoint theorem will come into the play. I hope this much is clear. Let's try an example on intercept theorem as well. So let's see. All right, I have a question here. Now remember one more thing before I solve this question. In intercept theorem questions, a lot of times it's not just a very solo looking intercept theorem question. A lot of times you will have intercept theorem mixed with midpoint theorem. In midpoint theorem, rarely an intercept theorem question is mixed, but it's not the other way around. Okay, so this is not a hack or anything. Just be alert when you're solving a question. If any mention of a midpoint is there, it's clearly talking about midpoint theorem or converse of midpoint theorem. Just be alert about this. Okay, so I have a diagram. I have a really nice looking diagram here. So the diagram looks like this. So this is my diagram. I'm just going to label it properly. A, Q, P, R, B, S, C, and D. What is the question telling me? The question says that in the given in the figure given below, 2AD is equals to AB. So question says 2AD is equals to AB. Now I can say AD is equals to AB by 2. I mean, I'm not doing anything special here. The question said 2AD is equals to AB. I change it as per my convenience. So AD is where? Here. And AB is where? Here. That means the AD part is half of AB. Okay. Now, P is the midpoint of AB. It says P is the midpoint of AB. So this means this part is equal to this part. And what we just saw that AD was equals to half of AB. So in a way, what I'm saying is AD is equals to AB by 2. That's my given information. But I'm also saying that AP is equals to AB by 2. And PB is equals to AB by 2. So that means I'm saying my AD, AP and PB are equal. Guys, I have not done anything here. The question clearly mentioned that AD is half of AB. The question also mentioned that P is a midpoint. Remember, P is a midpoint. That means we are possibly looking at a midpoint theorem situation too. So in a way, I just equated the three parts that they were saying that all are equals to half of AB. AD was half of AB, AP was half of AB, and PB was half of AB. So all three are equal. The first point, okay, they are also saying one more thing. Q is the midpoint of DR. So it says this part is equals to this part. Q is the midpoint of DR. And PR is parallel to BS. So they are saying that PR is parallel to BS. Look at this, guys. We have one midpoint. We have another midpoint. I mean, there is the question is crawling literally with midpoint theorem, right? And mind you, I'm picking this question from an intercept theorem exercise. But since there are so many midpoints and parallel lines, we are definitely going to keep that in consideration. Okay, this could help us. Okay, so the question says prove that AQ is parallel to BS. So that's the first question. We have to prove AQ is parallel to BS. Okay, AQ parallel to BS. Now please understand, AQ parallel to BS directly cannot be proven. Because if you see, the AQ has a connection with triangle DPR. So what I'm going to write, first I will explain you which triangle I'm looking at. Triangle DPR and my reason. So if you notice, I clearly know that AD and AP were equal. See here. So can I say that A is midpoint of PD? Can I also say that Q is midpoint of DR? How do I know this? It's given. I don't know this. It's given. The question has said that. So I have two midpoints. And when I have two midpoints, should I think of converse? No. I should think of the original midpoint theorem, which means that AQ is parallel to PR. Some of you would want to write AQ is half of PR, which is good. You would be correct if you write that. We just don't need the half right now, at least, but we will write. So AQ is parallel to PR, we have just proven. But the question said earlier that PR is parallel to BS. It's given, right? So I just proved AQ is parallel to PR, but PR was parallel to BS. Therefore, AQ will become parallel to BS. All right. Now we are going to move to the next part of the question. What is the next part of the question saying? It says DS, prove that DS is equals to 3 times RS. 3 times RS. Okay. Please remember, we have just shown, we had in the question, not shown, sorry. The question had mentioned that DQ and QR were equal, right? All I need is RS also to be equals to DQ and QR. That's all I need. This is where intercept theorem will come into the play. Now first, let me help you in spotting the three parallel lines. We have just proven that AQ is also parallel. That means I have AQ, I have PR, and I have BS. So I have three parallel lines. What are my transversals for these three parallel lines? BD and DS are my transversals. So I have three parallel lines, I have two transversals, I also have, because AP is equals to PB. How? Here. AP was equals to PB, right? And what does the intercept theorem say? Look at this. It says that if one set of intercepts are equal, then the other set becomes equal, right? So we come back to the question, what do we see? Because one set of intercept AP and PB are equal, that means QR should be equals to RS by intercept theorem. Therefore, I can say that DQ is equals to QR is equals to RS. And hence, I can say DS is 3 times RS. Why? The DS is the full length, if you see DS is the entire line and RS is one part of it. If you have one line in 3 equal parts, that means the full line is thrice the individual part. All right. So I hope I was able to explain you guys the midpoint theorem, the converse of midpoint theorem, and the intercept theorem properly. I tried my best with a couple of examples too. You're going to get more examples and more explanations on these theorems. For now, I'm closing the class. With more examples, I'll catch you up very soon in the next class. Thank you. Good night.